how many units of reaction do we see here? 2, 3, or 4 units of reaction. But hold on a second. What exactly is a unit of reaction? An example of one is 1H2O plus 1Cl2 yields 2HCl, because what we see here is a correctly balanced chemical equation, and visually speaking, the molecules associated with that. It uses the smallest whole number coefficients. In other words, we don't have fractions of molecules, and it follows the law of conservation, which means that we have the same number of each element before and after the reaction. So with our reaction of interest, we'll identify all the molecules in play, H2, O2, and water. Notice that there are 8 H2s, 4 O2s, and 8 water molecules. So let's see if it meets our criteria of a single unit of reaction. Spoiler alert, it won't, but this will still be super helpful. It definitely follows the law of conservation because there are 16 hydrogens on the left side, 16 on the right, as well as 8 oxygens on the left side, 8 on the right. In terms of coefficients, it's clear that these numbers are all multiples of 4, so they're not in the smallest whole number ratios possible. So this is not a single unit of reaction, but there's actually a really clear way of making it into one. Whenever we have this particular combination where this is followed and this is not, that means that the equation slash set of molecules we have represent multiple units of reaction. In other words, a single unit of reaction scaled by some number. Thus, if we reduce our coefficients down to their smallest whole numbers, 2, 1, 2, we by definition have 1 unit of reaction because we meet both criteria of a balanced chemical equation. At the top is a single unit of reaction, at the bottom is 4 times that. Therefore, we have 4 units of reaction total. And it's also really important to note that in comparison to a single unit of reaction, 4 units have 4 times the oxygen atoms, 4 times the hydrogen atoms, 4 times the atoms in general. This has 6, this has 24, 4 times the H2 molecules, 4 times the O2 molecules, 4 times the water molecules, and 4 times the molecules in general. 5, 20. Here's a table to guide you through this process, and really the key thing here is that for multiple units of reaction, everything's balanced, it's just we have too much of it. It's very much analogous to reducing 4 over 8 to 1 over 2. It's the same value, but we want to simplify it. Now, this is not to be confused with atom ratios, so I highly implore you to check out the video in the description on your screen to see exactly what I'm talking about and how it relates to the fact that we cannot have fractions of molecules.